In this video, we'll be discussing the different forms of a quadratic function and how to get from one form to another. We have the standard form, the factored form, and the vertex form. The standard form is represented by an equation that looks like this. F of x equals ax squared plus bx plus c. This is important because the y-intercept will be the c value. I will go into a further explanation about that later. Then the factored form is given by f of x equals a x minus r x minus s. And this is important because the x-intercepts will be the value x is equal to r and x is equal to s. Finally, my last form is the vertex form, and the vertex form is represented by a x minus h squared plus k, where the vertex will be the point x value having h and y value having k. I will do a few examples about how to get these values and what they mean in more detail, but for now, let's try and understand how I get from one form to another. If I'm going from standard form to factored form, I need to factor. If I'm going from standard form to vertex form, I need to complete the square. If I'm going from factored form to standard form, I need to expand. And if I'm going from vertex form to factored form, I would also need to expand. In the next part of the video, we will start trying to solve different problems by going from standard form to factored form, standard form to vertex form, and back to standard form. Now we will have a look at how to go from standard form, which is ax squared plus bx plus c, to factored form, which is represented by a x minus r x minus s. And as we said, going from standard form to factored form, all we have to do is factor. Let's look at an example. Let's take the example f of x equals x squared minus 5x plus 6. I have created my own method to factor, and that method is a reversed engineered method of expanding, because that's what factoring is. It is the opposite of expanding. If you'd like to have a look at that video, please check out the link above. So let's start trying to factor this quadratic. So I have x squared, which is made up of the factors x times x, and I have 6 on the end, which is made up of the factors of either 6 and 1 or 2 and 3. Now, because it's a positive number, the factors either have to both be negative or both be positive. And in the end, I want it to add up to negative 5x. So the factors I would need to use for this would be 2 and 3, with them both being negative. Because if I had to multiply the first term with the second term in each bracket, I would get minus 2x and minus 3x. If this doesn't make sense to you, please watch the video that I did, because I think it's a very good method to help you understand factoring. So my brackets will be these two brackets, which is equal to x minus 2 and x minus 3. To go from factored form to standard form, all I'd have to do is expand, since expanding is the opposite of factoring. So let's expand this together. F of x equals, now I would have to multiply these brackets out, which means I take every term in the first bracket and I multiply it to every term in the second bracket. So x will multiply x and become x squared. X will also multiply negative 3 and become negative 3x. then negative 2 would multiply x and become negative 2x, and negative 2 would multiply negative 3 and become positive 6. Together, that makes x squared minus 5x plus 6. That is exactly what we got in standard form. If you're enjoying this video, please don't forget to subscribe, and please comment below about what subject you would like me to teach next. To go from standard form to vertex form, we have to complete the square. If you're not sure how to complete the square, please watch the video above for more insight into how it works and also how to understand it. Let's take the following function in standard form and let's complete the square in order to get it into vertex form. X squared plus 6x minus 13. Now, in order to complete the square, we need a special number that will help us do that. That number is b over 2 squared. And I can only get this from standard form. Since this value of 6 is b over 2 squared will equal 6 divided by 2 squared. 6 divided by 2 is 3, squared is 9. So 9 is the special number I'm going to use in order to complete the square. So how do we use this number of 9 to complete the square? Completing the square means that I want to get a perfect square bracket. In order to do that, I need to use my special number. So that special number is 9. And what that will do is make this a perfect square bracket if I add 9 to the first two terms. But I still have a negative 13 to deal with. Now, in order to add 9, I cannot just decide to add it to a function, but I can also add it and subtract it. By adding and subtracting, I am doing a resulting addition of 0 to the function, so I actually haven't changed what the function is. Now, why would I do that? Because if I can group these together, the first three terms, using my special number that I got, I will be able to make a perfect square bracket. This would factor into x plus 3 multiplied by x plus 3. And then at the end, I still have a negative 9 minus 13. Negative 9 minus 13 is negative 22. From here, I can write x plus 3 as a single bracket, but it is now squared, minus 22. I have now got it into vertex form. Vertex form, a is 1, so I don't need to write that. It is x plus 3 squared minus 22. Let's now go back from vertex form to standard form. How would we do that? Well, again, we would have to expand. By expanding what we have on the right, we should get what we have on the left. So let's try expand that. F of x equals x plus 3 minus 22. Again, we expand by multiplying the first terms together and the first and the last term, everything in the first bracket multiplied by everything in the second bracket. So that would be x squared plus 3x, and this would be 3 times x and 3 times 3. 3 times x is 3x, and 3 times 3 is 9 minus 22. So finally, we have f of x is equal to x squared plus 6x and then minus 13, which is exactly what we have on the left-hand side with standard form. Let's now move from standard form to factored form and vertex form and understand why these forms are important. So f of x equals x squared plus 6x plus 8 will be my example. In order to get factored form, we would simply have to factor. if I factored this, it'd be x plus 2, x plus 4. And for the vertex form, I would need to complete the square. By completing the square, I would need that special number. So what I'm going to do is move the 8 to the side, and I'm going to add the special number, and I'm also going to subtract it. The special number is b over 2 squared. In our case, b is 6. So 6 divided by 2 is 3 squared is 9. So I would add 9 in order for this bracket to group, and I would subtract 9 also, so that I haven't changed the value of my function. This would become x plus 3 squared and minus 1. So why are these three forms important? Well, the standard form gives me the y-intercept. The y-intercept is when x is always equal to 0. So if x is equal to 0, my y-intercept would just be 8. Y would equal 8. So that's what we can get from the standard form. From the factored form, I can get my x-intercept. Since my x-intercept means that the y value is 0, I can solve this and get x plus 2, x plus 4, and that will all equal 0. The fact that two brackets are being multiplied, the first bracket is multiplying the second bracket, and it equals 0, that means one or both of the brackets should be 0. So that means x plus 2 should equal 0, or x plus 4 should equal 0. Solving each equation separately, I get x equals minus 2 and x equals minus 4. And finally, in vertex form, I am told that the vertex form is ax minus h squared plus k, where the vertex is h and k. So from this form, I can tell you what the vertex is. 3 is in place of minus h. So because it is a positive 3 and the formula says minus h, my vertex will be the opposite of that. My vertex will be negative 3, because a negative times a negative gives me a positive, and my y value of my vertex is the same as k, and that y value is 1. So from the standard form, we can see we get the y-intercept. From the factored form, we can easily get the x-intercepts, and from the vertex form, we can easily get the vertex. I'll be doing videos on more difficult examples, so please subscribe and like this video, and let me know what you want me to do next.